Graphing linear inequalities. A solution to a linear inequality is any ordered pair that makes the inequality true. So you all had ordered pairs. Some of them were true. Those are considered solutions. I'm going to do this example exactly like the ones that we just did on the board. I'm going to take the point, -3, 6. I know it has an x value and a y value. I'm going to plug in the x value and the y value. Y is 6. 2 times -3 minus 4. And I'm going to solve, simplify. Is 6 greater than -10?
Yes.
So we say yes.
Yes.
-3, 6 is a solution. Example 2, I do the same thing. I'm going to take my x and my y value and plug them in. 3 times -7 is less than -2 times 3 minus 5. I'm going to keep simplifying this. What do we think here? Is -21 less than -11?
Yes.
That one is also true. Even though it looks like a bigger number, remember that negatives, when they go more negative, they look bigger. So this, I would again say yes. 3 -7 is a solution. Questions on that? That's all you're doing. To determine if something is or is not a solution, we just plug it in. Okay, so now we're going to be graphing them. We are going to graph these inequalities essentially the same exact way that we graph lines. Do we remember how we graph lines? Maybe it's been a minute. We need them in what form in order to graph lines? Slope-intercept form. So y equals mx plus b. Except the difference when we do inequalities is what? What's the difference when we do inequalities versus y equals mx plus b? There's not going to be an equal sign. Instead of an equal sign, it's going to be a greater than, less than, greater than or equal to, less than or equal to. Linear inequalities also have more solutions than just the points that fall on the line. So that's what we were seeing when we were doing our little points. There's a bunch of solutions on the left side that don't lie on that line. Therefore, what we're going to need to do is do a little bit of shading. If you like highlighters, you might want a highlighter. Otherwise, we can just use our pencils. It's going to be okay. So, there's two things we need to be paying attention to. Whether our line that we graph is going to be a solid or a dashed line. And then the second thing is where we are going to shade our graph. So, talking about solid or dashed lines. We want to think about when we did inequalities way back in Unit 3, I think it was, when we did open and closed circles. Do you remember that? So, when we had a closed circle, that's essentially the same thing as a solid line. That is anytime we see a less than or equal to, greater than or equal to, or less than or equal to. Anytime we have those equal signs, we're going to have a solid line. Then on the opposite, when we have a open circle, that's the same thing as like a greater than or a less than without that equal sign. Good? That's the first part. The second part is now, where do we shade? So I'm going to draw you two little graphs here. Do we shade above or below my line? Well, let's give an example for what does above look like. So let's imagine I have a coordinate graph. I'm going to draw in a line. I am going to shade above this line. Think about if you dropped a marble on this line, what side would it hit? Obviously, it wouldn't hit the bottom of this line. That would be anti-gravity. It would hit the top of this line. That is the above portion. And we are going to shade above my graph anytime I see greater than or equal to. So if it's greater than or equal to, we shade above my line. So then it makes sense that when we go below the line, So I'm shading below the line. Again, think about dropping that marble. It would never touch this side because that's anti-gravity. That's going to happen when I have a less than or equal to sign. So there's two things we're paying attention to here. Solid and dashed lines, and whether we're shading above or below. Questions? Okay, let's look at the examples. I need to start these pretty much by graphing my line. To graph my line, I need it in a graphable form. The graphable form is still slope-intercept y equals mx plus b. If it's not in y equals mx plus b form, I can't graph it. So for this one, I need the y to be by itself. I'm going to add 6x to both sides. Oops, that's a 4. And then I'm going to divide everything by 2. So there's my equation. It looks like slope-intercept form, y equals mx plus b. The only difference is that there's not an equal sign in it. There's an inequality symbol in it. So before we even get into like the new stuff, what's my slope? What's my y-intercept? The slope is 3. The y-intercept is 2. Okay, so that's just like the stuff that we need to know to just graph a regular line. Now I need to determine the fancy stuff, which is number 1, are we going to have a dashed or a solid line? Why do we know it's solid? Because of this equal sign right here, I know that because I have this line, I need a solid line. So now let's draw that solid line. I start at my y-intercept of 0, 2 on the y-axis. I'm going to use my slope of 3, rise over run, which is 3 over 1. So I'm going to go up 3 over 1. Let me give you rulers now that you're graphing things. Well, you're going to need a ruler for your homework for sure. Okay. You already have one? How am I out of rulers? Where are all my rulers?
I need some yet.
I'm low on rulers. Who's got multiple?
Oh, no.
He's breaking them, I wonder who.
No, I got higher.
I jumped
Okay, grab your line. Solid line,
I
please.
think that one.
I would like a ruler.
Grab your line.
No.
Branson, you're getting on my nerves.
You can come sit by me.
Yeah.
Me and Branson can share rulers if you come sit.
No.
Yeah, I'll share.
Cody, can you give me a ruler? I don't have a ruler. I don't have a ruler.
Oh, let's say I should share it to sacrifice my ruler.
All right, everybody got this solid line?
Branson's looking at me.
Do we want to shade above or below this line?
Above.
Why above?
If it's greater than or equal to. Branson.
Because we have that greater than, we are going to shade above. So some people really like to first draw arrows. I know I sometimes like to visualize where my shading is going to go. So you know that it's going to go above that line. And then we're going to nicely, neatly fill this in. As nicely, neatly as we can. I should be able to tell where your shading is. I should be able to tell that your line is solid. If I cannot tell, you're going to get a 0 on the quiz because I'm not going to sit and guess whether your line is dashed or not dashed.
I think Branson's trying to sleep.
Good on this one? All right, let's do it again. Are we in y equals mx plus b form? So I need to first get it into y equals mx plus b. I'm going to subtract 9x. And then what do I do?
Divide by -3.
And what happens when I divide this inequality by a -3?
Oh, it switches.
my sign flips. Do you remember that rule?
Yeah.
So dividing or multiplying by a negative on both sides flips the sign. Write that rule down. It's been a couple units since we've seen it, but you cannot forget that when we divide or multiply by a negative number on both sides, we need to flip that sign to face the other way. So instead of greater than or equal to, now it says less than or equal to. This is really going to change the way your graphs look. Slope? What's the slope? What's the y-intercept? Is our line going to be dashed or solid? Let's go ahead and graph that first. I'm going to start with my y-intercept at 4. Okay, and now what do we think, above or below? We have that less than symbol. Be careful, don't look at the original because we flipped it. We are shading now below. And again, what this is telling me, just like we did in that warm-up, is that if I put a point anywhere in that shaded region or even on the line, I should get a true statement. If I put my point anywhere not in that shaded region, I'm going to get a false statement. Any questions on that? All right, so example 5, same deal. I'm going to solve for y. I need to get y equals mx plus b form. Oops. If I divide 3 by 5, I'm just going to leave it as 3/5 x. I'm not doing anything fancy with that. What's my slope? What's my y-intercept? -7. And then what do we think? Solid or dashed? Yeah. This one is going to be dashed because I do not have that equal sign underneath my symbol anymore. So I'm going to start with my point, -7 on my y-axis. And I'm going to go up 3 over 5. Up 3 over 5. And I'm going to draw a dashed, the best dashed line I can draw through these points. And it needs to be clear, once again, that this is dashed. If I can't tell that your line is dashed, I'm not guessing. You're just going to get a 0. Yes. All right, and then what do we think? Are we shading above or below, Jay?
Sorry, Jay.
Oh, what do we think, above or below?
Below.
Branson? I have a less than symbol. I'm shading below this line. I want us to think about, really quickly here, what happens if I plug in, let's say, this point right here? Okay, if I plug in the point 0, -7 into this equation, do we think it's going to be true or false? Look at how this lands on the dashed line. If it's on the dashed line, think about the open circle. Do we ever include the open circle? No. So if I land on the dashed line, like the point 0, -7, I'm going to get this statement, which is a false statement because anything on the dashed line is not a solution. It's dashed. That's not the same as a solid line. One more like this. Kind of a weird one. What do we think about this weird one? There is a slope. The slope is 0. Do you remember the acronyms that I told you? Hoy and Vux. Is this Hoy or Vux? This is Hoy. So what's the slope? Because of the y. The y tells me this is Hoy. So the slope is 0. And what kind of line is this going to be? What does the H stand for? Horizontal. So I want a horizontal line through where y is -2. So I'm looking at my y-axis. Here's where y is -2. We're going to draw a horizontal line. Is that horizontal line going to be dashed or solid? It's going to be dashed. It's dashed. Because this does not have an equal sign on it. If it has an equal sign, that's when it's solid. If it does not have an equal sign, it's dashed. And then what's our y-intercept? What's the y-intercept? And then what do we think? Are we shading above or below this line? Above. Y is greater than -2. So everything above this line gets shaded. Okay, now we need to go backwards because we can graph these, but now can we write them? We're not done. I want to do a number 7 first. The way we're going to do this, we know that my equation of a line looks like y equals mx plus b. Except instead of an equal sign, we're going to replace that with an inequality. So let's kind of like fill in the blanks. I don't know m, I don't know b, I don't know the inequality. So I'm going to have y, some sign in there, m, which I don't know, x plus or minus b. Then I look at my graph. I need the slope and I need the y-intercept. What's the y-intercept here? The y-intercept is 1. The slope is
2.
If I pick points, I'm going up 2 over 1, so my slope is 2. So let's fill that in. 2x plus 1. Then I think, what sign do I need here? Less than or greater than? Less than because it's below. And it's equal to because the line is solid. Perfect. Okay, do the same thing. I need m and I need b. What's my y-intercept? What's my slope? Up 1 over 2. That's 1/2. Oops. What? No. And then what do we think about our inequality? Is it going to be greater than or less than? Is it going to be equal to or not equal to? Not equal to because we have a dashed line here, not a solid line. Perfect. Do those two make sense? Okay. The last one is weird, and I need us to pay attention to this one really hard, okay? What kind of equation is this? It's not y equals mx plus b. What does this equation look like? It's x equals, because, think about my acronyms. I just talked about them up here, didn't I? If I have, this is a vertical line, I'm thinking of Vux. That x tells me this is going to be x equals some number. What number, first of all? X equals what? 3. Is this going to be a solid or a dashed? I mean, this is a dashed line, so is it going to have an equal sign or no equal sign?
No equal sign.
Okay, and then here's the tricky part. Which way does this face? Greater than or less than?
Greater. Less than.
Think about it. If this is 3 right here, this is 2, 1, 0, -1, -2. Are those numbers less than 3 or greater than 3?
Less than.
So if I'm pointing towards the numbers less than 3, I should have a less than symbol in there. Any questions on that?